Hello, and welcome to Math with Mr. Bill. I'm Bill Anderson. Today we're going to be talking about finding the intervals where a function is increasing and decreasing. And we're going to do this for the function f of x equals x minus 1 over x cubed. So to discuss where a function is increasing and decreasing, we need to find the derivative. Because if we know where the derivative is positive or negative, then that will tell us when the original function is increasing or decreasing. So let's find the derivative first. So because we've got a polynomial divided by a polynomial or a function divided by a function, then we're going to be using the quotient rule. So if we have a quotient, some g of x over h of x, and we want to find the derivative, we take the derivative of the top and multiply it by the bottom, and then we subtract the top times the derivative of the bottom, and that's all going to be divided by the bottom squared. So our g here is being played by x minus 1, and so g prime then is just going to be 1. H is going to be x cubed, and h prime then will be 3x squared using the power rule. So now plugging this into our quotient, we get that f prime of x is equal to g prime, which is 1 times x cubed, minus g, which is x minus 1, times h prime, which is 3x squared. And this is all over x cubed squared. So now we're going to take the top here and we're going to distribute the 3x squared and the negative. So we get x cubed minus 3x cubed plus 3x squared all over x to the 6th. So combine like terms, and there we have it. There's our quotient. We can do a little bit more simplification because both terms in the top have an x squared, and that's not going to completely cancel our denominator. We wouldn't want to do this if we took out the denominator completely, because that would get rid of a place where the derivative could change direction. But let's go ahead and do that. Let's go ahead and pull out an x squared out of the top. So we get minus 2x plus 3 on the inside, and all of that's over x to the 6th. And then we can cancel x squared and x to the 6th, and we finally get our simplified derivative, negative 2x plus 3 over x to the 4th. Now we want to know where this derivative is positive and negative. And the only place that it's ever going to change from positive to negative is where the numerator and the denominator are individually equal to 0. So if I set both of those equal to 0, I get negative 2x plus 3 equals 0, and I get x to the 4th is equal to 0. So solving the first equation, I get negative 2x is equal to negative 3. And so at x equals 3 halves, that's a possible place where the derivative is going to change sign. And then for the numerator, or the denominator, then x to the 4th is equal to 0. That tells me that x is equal to 0. Is another place where the function could change direction. So I'm going to draw a number line so I can determine which sign the derivative is around those zeros. So I'll plug in 0 for the denominator there, and then 3 halves for what makes the numerator 0. And then I'm going to take test points. And so I'm going to take something to the left of 0, say negative 1. Something between 0 and 3 halves, let's say 1. And then something greater than 3 halves, like 2. And I'm going to plug this back into my derivative. So f prime of negative 1. Plug this into your calculator or evaluate this by hand. We get negative 2 times negative 1, which is 2, plus 3 is 5, all over negative 1 raised to the 4th, which is positive. And so that's a positive number. And so the derivative all the way up to 0 is positive. So now let's look at the region between 0 and 3 halves. Let's plug in 1. So f of 1 is equal to Negative 2 times 1, which is negative 2, plus 3 is 1, all over 1 to the 4th, which is 1. And so again, that section from 0 to 3/2 is positive. And let's plug in 2 for our last section. So we get negative 2 times 2, which is negative 4, plus 3 is negative 1, all over 2 to the 4th, which is 16. So it's negative 1/16. So this is negative right here. So the region from 3/2 onwards is going to have a negative derivative. So what does that tell us? That tells us from negative infinity to 0 that the function is going to be increasing because the derivative is positive. Likewise, between 0 and 3/2, it's also going to be increasing. From 3/2 onwards, though, the derivative changes to a negative, and so it's going to be decreasing. So we can list out our intervals of increasing. We just have to make sure that we don't include 0 because 0 is not allowed in our original function. And so our intervals for increasing go from negative infinity to 0. And we close that off with an open parenthesis. And then we union that from 0 to 3/2. We use a closed parenthesis there because at the end point, we don't say that it's either increasing or decreasing. And then it's decreasing from 3/2 all the way to positive infinity. So that does it. We've described what the function is doing, where it's increasing and decreasing, and talked a little bit about what happens at the discontinuity at 0. And that should do it. That should answer our problem. And thanks, and I'll see you in the next video.